Hi, this is Dr. MSNA Prasad, Assistant Professor, Department of Chemistry, Institute of Aeronautical Engineering. In this session, I am going to discussing about corrosion. What is the corrosion and what are the major causes for corrosion and what are the major effects due to the corrosion process. Here, corrosion is nothing but destruction or decay of material. This destruction process takes place by either chemical or electrochemical attack on the surface of the metals. In chemical process of corrosion, whatever different types of chemicals which are present in the environment and these are surrounded by the metals. Because of these chemicals, metal will undergoes decay. So this type of process is known as chemical corrosion. It is also known as dry corrosion. Whereas in electrochemical type of corrosion, destruction or decay of matter by the moisture present in the environment. Electrochemical corrosion also known as wet corrosion. Why? Because electrochemical type of corrosion takes place due to the presence of wet conditions of the environment. So that's why corrosion is the nothing but chemical or electrochemical reaction between the materials and its environment that produces deterioration or decay of the material and their properties. So, major properties of the metals will be rules by the process of corrosion. So, coming to the definition of the corrosion, the deterioration of material by chemical interaction with their environment. The term corrosion in sometimes also applied to the degradation of plastics, concrete and wood. But generally it refers to the metals. So humans have most likely been trying to understand and corrosion for a long as they have been using metal objects. The most important periods of pre-recorded history are named for metals that were used for tools and weapons. For example, Iron Age, Bronze Age, with a few exceptions. Metals are unstable in ordinary aqueous environments. So metals are usually extracted from ores through the application of considerable amount of energy. Certain environments offers opportunities for these metals to combine chemically with elements to form compounds and return to their lower energy levels. Usually, metals are highly reactive. So, usually metals present in earth crust in a combined state, that is qualities O. So, during extraction process, some amount of energy applied to this ore. Hence, metal has been separated from this ore. So during this extraction process, metal will become unstable and highly reactive. So it ready to react with whatever environment factors which are surrounded itself. So corrosion is the primary means by which metals deteriorate. Most metals corroded on contact with water, acids, bases, salts, and aggressive metals, polishes, and other solid and liquid chemicals. Metals will also corrode when exposed to gaseous materials like acid vapors and formaldehyde gases, ammonia, and sulfur containing gases. So, what are the major causes for corrosion? Acids and alkali, salts, mercury, water, and air, which are surrounded to the metal. So, as we know, different types of acids present in the environment, like HCl, H2SO4, and nitric acid. Different types of acids are present. Number of acids are present in the environment. Similarly, alkali. Alkali is nothing but bases. Here also number of bases present in the environment. And salts, sodium chloride, ammonium chloride, etc. etc. And mercury and water. So moisture also present in the environment. Air, air in the sense oxygen. So decay or destruction of material by the attack of these foreign substances, that is a major cause of corrosion. And moreover, interaction between the two or more electrochemical surfaces, for example between steel and zinc metal, and a metal surface and atmosphere, Co- corrosion on the piping in the industrial boilers, soil and metal surface, the corrosion which happens on the bottom of the tank and underground pipe. And major causes of corrosion, that is the nature of the metal or alloy. So corrosion process also depends on nature of metal, that means reactivity order. So depends on position of the metal in electrochemical series also affect on the rate of corrosion. Second one, presence of inclusions or other foreign matter at the surface. Homogeneity of the metallic surface structure. Nature of the corrosive environment, like acidic environment and basic environment, which is surrounded to the metal. Incidental environment factors such as variations in presence of dissolved oxygen and temperature and velocity of movement either of the environment of the system itself. And other causes such as stress and presence of deposits on surfaces and fade surfaces and possibility of corrosion crevices, and incidental presence of stray electrical currents from external sources, and depends on nature of the environment. Basically, destruction process has been classified into two types, that is dry corrosion or wet corrosion. So let me now, what is the difference between the dry and wet corrosions? First, coming to the dry corrosion, it is involves direct attack of dry gases like air and oxygen on the metal through chemical reactions. As a result, oxide rain is formed over the surface. This type of corrosion is not a common. Next, second type of corrosion, that is wet corrosion. It involves direct attack of aqueous medium like strong, dilute, acidic or basic nature of the environment on metal through electrochemical reactions. Here, wet corrosion process, the mechanism of wet corrosion is look like electrochemical cell. So we know that what is electrochemical cell. Here, anode and cathode electrolytes are present in the cell. Anode and cathode are connected with external circuit. So if we observe the mechanism of wet corrosion, it is very similar to the construction of electrochemical cell. Here, if you take some metal, if you say metal, so the part of the metal which is exposed to the environment act as a anode, and rest of the part of the metal which is not exposing to the environment act as a cathode. And environment or nature of the environment in which metal present, that is act as a electrolyte. Electrolyte. So that's why we can call it is wet corrosion is also known as electrochemical corrosion. Next, how we can prevent or control the process of decay. The corrosion may be prevented or controlled by following ways, that is selection of proper material, proper design of equipment, coating and drying of the equipment, altering environment, inhibitors, cathodic protection, and anodic protection. So these are the major controlling methods of corrosion. So let us see one by one. Selection of proper material. Corrosion should not permitted in fine wire screen or fish and other items in which the dimensions are critical and change is not permitted. In some cases, non-metallic materials will be more economic and have good performance. It should be considered if their strength, temperature, and design is satisfactory. The corrosion characteristics of chemicals and limitations of construction material can be considered. The processing conditions should also be considered. And second one, proper design of equipment. In the designing of equipment, the number of fittings like buffets, valves, and pumps should be considered. Corrosion can be minimized if the equipment design is facilitates. So we should eliminate the cleavages which are present on surface of the equipment, and we should complete drainage of liquids ease of graining, so ease of inspection and maintenance of the equipment. A direct contact between the two metals is avoided if they are separated widely in electrochemical series, or they should be insulated. And next one, coatings and linings of the material. Non-metallic coatings and linings can be applied on steel and other materials of the construction in order to combat corrosion. Coating methods. So here there are several types of coating methods on the surface of the metal. So if you coat the metal, we can prevent the or we can control the process of destruction. For example, electroplating, galvanizing, and cladding. The thickness of lining is important. Effective linings can be obtained by bonding directly to substrate matter or building multiple layers. So usually organic coatings, nothing but paints, can be used in tanks, piping, and pumping lines. A thin reinforced paint like coating of less than 0.75 mm thickness should not be used in services for which full protection is required. The cladding of steel with an alloy is another approach to this problem. So, SP glass can be bonded to steel so that the liner is 1.5 mm thickness with is impervious in nature. Piping and equipment lined in this manner are used in several corrosive acid services. And fourth controlling methods of corrosion is altering environment. Corrosion can be reduced by employing following conditions, that is, removing air from boiler feed water prevents the influence of water on steel, reducing the temperature, eliminating the moisture, reducing the velocity of turbulence, shortening the time of exposure, pumping the inert gas into solutions, reducing aeration. Next, inhibitors. The corrosion inhibitors are added to the environment to decrease destruction of metals. So usually this forms protective films on the surface of the metals. These protective films are several types, that is absorption type, adsorbed on metals, scavenger page type, example remove corrosion agent, vapor page type, sublime and condense on metal surface. Inhibitors are generally used in quantities less than 0.1% by weight. And some more inhibitors, that is chromate, phosphate, silicates, protect iron and steel in aqueous solution, and organic sulfide and amines protect iron and steel from acidic solution. Copper sulfate protects stainless steel in hot dilute solution of H2SO. Next, one more protective method, that is cathodic protection. So, especially we can observe or we can apply cathodic protection and anodic protection in case of wet corrosion or electrochemical corrosion. wet or electrochemical corrosion. So it is a type of electrochemical cell. Hence, the type of this mechanism of electrochemical corrosion, it is a look like construction of electrochemical cell. That's why we can apply cathodic protection or anodic protection in case of electrochemical corrosion. So first, let us see the cathodic protection. So it is a based on galvanic action between the metals of the anode and cathode suspended in a solution. The metal to be protected is made a cathode and electrons are separate. Thereby dissolution of matter is suppressed. So cathodic protection can be achieved by sacrificial anode method and impressed current or EMF method. Sacrificial anode methods. So in this method, anodes are kept in electrical contact with metal to be protected. Here, usually highly reactive metals are used as a anodes. Hence, concentration of corrosion takes place on the surface of the anode. So anode will be corroded to protect the cathode. The anode are sacrificed since it goes into the solution. For example, the protection of iron and steel tanks, the metals such as zinc, aluminum, magnesium, and their alloys are used as a sacrificial anodes. These are used in limited pH range. Anode material is selected from electrochemical series. Anode should not be poisonous and not detrimental to the products. Impressed EMF method or impressed current method. So it is also known as applied current system. That is, external voltage is impressed between the tank and electrodes. The negative terminal of a power is connected to the material to be protected from corrosion. So the natural galvanic effect is avoided and the anode is maintained positive. Since anode is not consumed, metal or non-corrodable material can be used. So let us see what is the major advantages due to the immersed current method or cathodic protection method. This method is used for large tanks to store mild corrosive liquids. In these cases, mild steel is used with negligible corrosion. And cathodic protection method is simple and the most effective. And it is very less expensive. It enables the use of cheaper materials for plant construction. And coming to the disadvantages, corrosion cannot be used to reduced to zero. Next, coming to the one more corrosion control method, that is anodic protection. So in this method, a predetermined potential is applied to the metal specimen and the corresponding current changes are observed. So during the initial stage, the current increases, indicating the dissolution of the metal. When current reaches a critical point, passivation occurs, that is, the oxide layers set in suitable oxidizing environment. The potential at the critical point is called passivating potential. So above this passivative potential, the current flows decreases to very small value called passivating current. The passivating current is defined as minimum protective current density required to maintain passivation. So at this stage, an increase in potential will not be corrode the metal since the latter is an highly passive state. So in case of stainless steel, titanium becomes easily passive and cannot offer cathodic protection. And advantages. The anodic protection method is utilized in transportation of concentration H2SO4. And disadvantage of anodic protection is corrosion cannot be reduced to zero, and this method cannot be applied for metals which do not passivate. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.